Okay, let's try this again. Right here, big star. All cells have a cell membrane. Okay. Then by default, doesn't that mean everything alive has a membrane? Every cell has a membrane. All living things have a cell membrane, right? Yes. So prokaryotic cells, eukaryotic cells, which covers all living things, all have a cell membrane. Why is the plasma membrane like a spaghetti strainer? Brian?
It allows water to go through?
Yes, and more. What else? It allows, could I pour, what were you saying? It does. So plasma membrane, it lets some things go through, ... but not others. Because when you put the strainer up there, does it let everything go through it? What's it called out? If we're making spaghetti, what does it not let go through it? Spaghetti, okay? This is the big thing we're going to talk about a cell membrane. We know that it's in every cell in our body, or anything that's living, and that it controls what goes through. So that's why we say that the cell membrane is the gatekeeper. The gatekeeper. It controls what goes in and out. Yeah. Okay. What three names does the membrane have? What do we call it? One of them's at the top of your paper. What's it called? Cell membrane. So there's one of them. It's called the cell membrane. Okay. What else? Plasma membrane. Boy, if you get the next one, I'm going to be impressed.
Hydrophobic? I don't know.
Plasma membrane. It's called a fluid mosaic model. And this is a new term. And this has actually been done by the research. What does fluid mean? A liquid. But is it just water? Do we have other fluids? Yeah. If you go to the Jiffy Lube store, they don't say, what do they say? Would you like your oil? That's a liquid, right? Or it's a fluid. Yeah. Yeah, there's another one where they say, would you like your fluids checked? All right. So, this is part review here. List all the kingdoms of organisms, verify and label if they have a cell membrane or not. Well, we know they all do now. But let's see if we can get through our 5 kingdoms. Nyla. Animalia is one of them. We'll just put animal. Just a second. Animal. Fungi. Huh? Plantae. Plants. Protista. And not Monera. That's the old term. Now what we put in here is bacteria. Bacteria, and it goes yes, 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 yes. On the yes column. Okay? We good? Alright. So I want to answer these very easily. Okay? Just so we get a little more understanding of the vocabulary. So what's a lipid? It's a fat in this case. So we're going to call this fat. What's a phosphate?
It's all the
It is, a phosphate is a chemical, but what we're going to talk about it here, or an element, what we're going to talk about here is it is the head part of a lipid, and it is polar. And if you remember, polar means that it has a plus side and a negative side. Just like what? Just like what? A what? Just like a magnet. What? When we were studying macromolecules, what did we say was a polar molecule? Water. This is really important. So keep that in mind when we talk about the rest of these. What does bi mean? Two. And what's a layer? If we were to stack up 3 layers or 4 layers of a big chocolate cake, what are we doing? Putting one on top of the other, right? Right. So now we're going to talk about one of my favorite things in the world. We're going to talk about peanut butter and jelly sandwich. How many layers does it have? 2. These are the bread. Okay, if I draw it up here, you want to draw it on your paper. So we got some peanut butter jelly sandwich going here, but first we're going to start with the bread. Blue bread? Blue only because it'll have a purpose later. Alright, so we got blue bread. Here's my question. I'm going to ask William, I bet William likes PBJ sandwiches. You like PBJ sandwiches? I'd rather have a PBJ sandwich than almost anything. If I take my PBJ sandwich and I stick it in the milk, does it absorb the milk? Make it all soggy? Yeah, so it likes water. There's no mainly water. So if I expose the bread to H2O, it gets sucked up. I get this side here exposed to water, it gets sucked up. Alright? Now, here's the question. What if I put a layer of peanut butter here? Good, thick, rich peanut butter. Does the water go through the peanut butter very easily? No. Okay? So we can say that the bread is the phosphate head. This is our phosphate head. It likes water. It likes water. There's a fancy name for that. We're going to talk about in a second. Now, how's the peanut butter feeling about it? Doesn't much like it. What do we know that doesn't go with oil? We say these two things can't mix. Water and oil. This is our fact. And we just made a phospholipid bilayer. This is a phospholipid. Here's the head. It likes water. Here is the tails. It has 2 tails on it. And they do not like water. Alright? So the way this looks is you have a head facing out, little tails, head facing out, little tails. The tails are the peanut butter. The heads are the bread. And we just made a phospholipid bilayer cell membrane. What does transport mean?
Take or carry.
Take or carry? Good, okay. Transport. I like to use the word, are you comfortable if I use the word movement? Okay, this is movement. Movement. That means take or carry. Hydrophilic. Hydrophilic means
Likes water.
likes water. So let's write likes water, and let's draw this right over here to these phosphate heads. Okay? Hydrophobic
It's not like water.
does not like water. And let's take that right up here to these tails. The lipid tails, that's where the fat is. A channel, and that is the best, thank you. So I've got 2 pieces of land that happen to have some water between it, and I can sail my boat up and down it. I can move using transport my boat up and down this channel. Our channel is going to look like this. Okay? It is a protein channel. All right. Okay, so semi-permeable means some things go through, others do not. Osmosis. We're not going to talk about osmosis. We're going to drop to diffusion. All right.
Moving of particles.
Just a Shirley, I need you. Diffusion. Okay, diffusion, just like we studied. Diffusion moves from, guys, you gotta get this, from a high concentration. What was the highest concentration? Guys? Ladies? Where was the highest concentration? Where's the most smell? Okay, from a high concentration to a low concentration. Concentration. All right. I know, I'm turning the fan. We're going to pull it out of the hall. All right, here we go. Here's the thing you need to know. Diffusion means anything, including moose stink. Okay?
It was pretty decent. It's pretty good.
All right.
It was like $10 for this thing.
All right, now, osmosis is exactly the same thing, but only water. Water moves from a high concentration to a low concentration. The only difference between diffusion is it means everything. Osmosis is the same thing, but only with water. Okay. Who remembers, review, what does homeostasis mean? What's homeostasis?
Internal stability.
Internal stability, but what's the word Mr. Smith always uses? Starts with a B. Balance.
So just for me to keep maintain now.
Balance. To maintain. Shirley?
I wasn't talking.
Oh, I'm sorry. To maintain. All right? That's what our cell membrane does. It allows, Bernard, do you ever make water balloons? I love water balloons, especially when it's hot. Okay, what happens if you forget to take the balloon away from the spigot as you're filling it up?
It's gonna blow up, right?
It bursts, right? Okay, that's what would happen. That's what our cell would do. We said that water could go right in. Why wouldn't it keep going in? What if none of it ever came out? What would happen to that cell? It'd blow up, it'd explode. There's a fancy name for that. Polar molecule. Has a positive and a negative in the water. Okay.